this lecture, we will build, deploy our Lambda function, and we will learn a few important things when it comes to declaring variables within a Lambda function. To do that, open the template.aml file, and instead of get output, we should be using the function called cold start basics. Paste it, save it, go to your project directory, sam build, and this time we are going to deploy it to the cloud environment because we want to see the cold start in action, how the Lambda gets warmed up, and how the same instance of Lambda will be used for multiple invocations. Sam deploy. While it deploys, I'll pause the recording. I'll come back once the deployment is done. It is complete. Now if we go to Lambdas, under services, Lambdas, we should see our Lambda function deployed there. Click on this guy, the Java Lambda, the first Lambda hello function, and we will test it. And then go check the logs. Click on test. We don't have to provide any input, so you can simply pass in empty JSON like that, open and close bracket. Call this test configuration. Scroll down, create, and click on this test button and quick session. Once it finishes, click on it again. And that has succeeded, execution is success. Click on it again 3 times. So totally we have invoked the Lambda function 3 times. Now you can check the details of the last Lambda invocation here. But to check all the logs, you can go to the Lambda function itself right here. Go to monitoring and click on view CloudWatch or view logs in CloudWatch. That will open up a new tab. And we can go to the log stream below once it opens up. Click on that log stream. It will have the logs from the 3 Lambda invocations within the same stream because the same instance of the Lambda was used. Let's look at the logs here. The start and the end mark a particular Lambda invocation start and end. The request ID, as you can see, is unique for each Lambda invocation. But the key here is that the same Lambda is being used. See this static block executed. So for the very first time, the Lambda is loaded and all this happens. So a host environment is created. Then we have the JVM being created, then the Lambda Java runtime, and finally the Lambda itself is instantiated. The Lambda class is instantiated only once. The class is loaded into memory. That is when this static block is executed. Then it will use the constructor to instantiate the Lambda class, and then this guy here, it says static variable, local variable. This is coming from the function invocation itself. This function here is invoked and the output can be seen here, a random value for instance variable, static variable, and local variable. But the key point, close this, go to the next start. See this, start again. Look at the instance variable. The random value you see here and the random value you see up top here is the same. So it is using the same Lambda class instance. It will not create a new instance unless required. It will try to use the same instance and the same environment when available. There is no guarantee how long this environment will be up. That time keeps changing. It is not documented anywhere. At least I couldn't find it. So that process is called cold start. For the very first time, it will take some time for this entire environment to be set up. But if we are sure that within our application, we are going to hit that Lambda several times at a given point in time, we can have that Lambda up. And for the consecutive calls, for the first hit, it will take some time for this environment to be created. From the second time, the entire environment is available, the context is available. The same Lambda function instance will be used to serve the request. That is the reason you are seeing the same. See this instance variable is the same. The static variable is also same as the up top here. Only the local variable, the random value assigned to this local variable keeps changing because this function will be called every time we trigger the Lambda, whereas the instance is not created again and again. So you see all these 4 things happening only the very first time the Lambda is triggered. The second and the third time you don't see the static block getting executed, the constructor being invoked. You just see this guy, the cold start basic, getting executed, and you see this out in the second and third time. The third time is right here. But you can see that the instance value of the instance, the random value is same that got assigned to the instance variable. Even on the third time, the static variable's value is the same, but the local variable's value, the random value that gets assigned is different because that gets invoked every time. So what we are trying to prove here is that if you have expensive operations that you are doing across lambda functions, then you better place them here globally as fields, either static fields or instance fields, so that they will not be created again and again, and they can be used across lambda function invocations. More on cold start in the sections at the end, but these are the basics. You need to understand that whenever a lambda is triggered for the very first time, the entire context is created. That is when the lambda function, this class is loaded into memory, then an instance is created, the static blocks, if they exist, which is very rare, get executed. The constructor is used to create the instance, at which point these fields here are initialized, but the lambda function itself will be invoked. It will have its own stack for every time the lambda is triggered.